Hello, Internet. We're going to do a little video about conceptually how to find the area of triangles. We're not going to talk about a formula here. That's just for you guys just to kind of take a look at these shapes and take a look at what we know about areas of rectangles, what we know about parallelograms, and to see if we can kind of just get a sense for what these shapes, how to find the area of these shapes. So I've got this look-in shape. We've got an acute triangle, an obtuse triangle, and I have two of them. I'll show you why we're going to look at the area in a couple different ways. And then we've got a right triangle down here. So the right triangles, obtuse triangles, and then the acute triangles. So let's start with the one that's the easiest to kind of take a look at, and that's the right triangle. So the right triangle I feel is the easiest to kind of get a sense for. I'm looking at it first because it's got this right angle here, and if we take this triangle and let's make a copy of it. So we're going to copy it and let's paste. And if I take this triangle and I rotate it 180 degrees, so if I turn it upside down, so let's do that. So let's rotate it. Let's rotate it left 90 and let's do another 90. Rotate it another 90 to the left. And you'll see that if I just flipped it upside down, rotated it 180 degrees, it would match up real nice and make this beautiful rectangle. And if I want to find the area of this rectangle, that's just not that difficult. So the height of the rectangle is 1, 2, 3, 4, 5, 6 units, and the base of the rectangle is 3 units. And if I wanted to find the area of the entire rectangle, well, I would do that. And let's actually put that. Let's put area of rectangle. So area of the rectangle would be the height of the rectangle times the base, or base times height, or 6 times 3 works as well. So the area of the rectangle is 18 square units. And we can count that, right? There's 1, 2, 3 squares. That's another 3, 6, 9, 12, 15, and 18. 18 square units. But remember what we were asked to do. We wanted to know what the area of just the triangle is. And yeah, we doubled the triangle to get this rectangle. So if we just want this triangle, we're looking for half of that rectangle. So if we're looking for the triangle, well, we would need to take the area of that rectangle and cut it in half. Area of the triangle would be the rectangle, but divided by 2. We needed to cut it in half, right? Divide by 2. You usually see it like this. Divide it by 2, which would be 9 square units. 9 square units. And I want to verify that. We've talked about how can we cut this triangle, so that's 9 square units for just the yellow rectangle, or just the yellow triangle. And we talked about, well, how can we turn this into a rectangle or a square itself? And if we take the height, which is 6 units, right, and cut it in half. If we cut it right in half, right there, and fold this piece down, we'll end up with this. We'll end up with this here. We'll end up with this triangle piece, and we'll do it in blue. We'll do it in green. So this triangle will fold down and be this triangle right here. So in total, we've got this here, which is now not a 3 by 6 triangle, but we have a 3 here, 3 units there, and a 3 by 3. So the area of this triangle, or area of the square here, which is 9 square units. 9 square units. All right, so either way, either we could double the triangle and find the parallelogram that's been made from that, and then cut it in half, or it looks like we can cut the height in half and bring that over. Let's see what that looks like for a different shape. Let's leave that one for later. It tends to be the most difficult one. So let's take a look at this triangle here, and we can cut this triangle in half for the height. We'll do that in a second. But let's try that way where we where we doubled this triangle and rotated it. So let's do that. Let's copy it and let's paste it, and then let's rotate it. So let's rotate it again 180 degrees so it flips upside down. All right, so rotate it and rotate it the same way. And if we match the corresponding side lengths, then we have this parallelogram again. So this parallelogram is not quite as easy to calculate the area of. It almost is. Then as a rectangle, all we need to do is remove this triangle. So go from one corner, draw a perpendicular line to the other base, either from here down or from here to here. And I'm going to remove this triangle and bring it on over here. So I'm going to move that triangle, slide it on over. Let's do it a little bit nicer. And we end up with a beautiful rectangle. Now this is the area of the rectangle. So this is the rectangle here. So how many square units in this rectangle? Well, it is, it is a 1, 2, 3, 4, 5. It's 5 units. And the height, 1, 2, 3, 4, 5, a 5 by 5. So the area of the rectangle is 5 times 5, which is 25 square units. I'll write it like that. And how can we find the area of we're just looking for the area of one of the triangles. So remember, it's not looking for both of them. We're just looking for one of the triangles here. So how are we going to find the area of this? And yeah, since we doubled the triangle to get this rectangle or parallelogram, we need to cut it in half to find the triangle. So the area of the triangle is half, is 25 divided by 2, which is 12 and a half. 12 and a half square units. So that's the area of the triangle. It's half of that rectangle. If we wanted to cut it in half, this is kind of interesting because the height of the triangle is that is a little crooked. Height of the triangle 5. So if we find the halfway mark here, well, that'd be 1, 2.5 units. So that's where we would make our cut. And if you notice, we have 2 slanted edges. So we're going to take this part of the triangle and flip it down, and we'll get here. And then we'll take this part and we'll fold this part down. And we'll have this. So we will have this rectangle, and that rectangle will be let's get the whole thing. So it's going to be how many units across? So it's going to be 1, 2, 3, 4, 5 units across, and 2.5 units is going to be the height. So we've got 5 units across and 2.5 across. So the area is 5 times 2.5. And 5 2 times is 10. And 5 half of a time is 2.5, which is 12.5 square units. 12.5 square units. So both ways. So we could double the triangle to find the rectangle or the parallelogram and then cut it in half. Or you can just cut the triangle in half along the height and fold the top down. Let's see if those two methods work for this one here, this obtuse triangle. The answer is yes, it does. So if you're liking one of these methods or both these methods so far, use whatever one you like best. So if we double this triangle, so if we copy it and paste it and then rotate it 180 degrees, we'll have a beautiful parallelogram. All right, we'll have a beautiful parallelogram. And again, to find, remember, we're just going to want one of those guys, but to turn this into a rectangle, which is easier to find the area of, let's make a cut along the height of this parallelogram. perpendicular with the base. So we'll make that cut there. This is going to be 3 units along the side. We'll move this triangle over, and we'll have this. We'll have this shape here. So this, and I'll go ahead and do this in dark red. There we go. There is our rectangle. Now it's a 3 by 1, 2, 3, 4. A 3 by 4. But remember, we just wanted the area of just one of those rectangles. So we just want the area of that rectangle there. So even though we cut a piece of this yellow, a piece will be over here, and a piece of that will be up here. So the area of the rectangle so that's my abbreviation. The area of the rectangle is 3 times 4, which is 12 square units. But the area of the triangle is just half of that, because we doubled the triangle to get what we have here. So it's 12 divided by 2, which is 6 square units. So let's see if we can verify that by cutting this shape in half along the height. So first of all, what's the height of this triangle? The triangle's height goes from the vertex straight down, so it will be perpendicular with the base. So here's the base here. Here's the base. And we need to actually extend it in order for that to be possible. So there is the height of the triangle, and it is 1, 2, 3. I guess I could have made this easier for us. So the height of the triangle is 3. So we want to cut it right in half, which would be 1.5. So if we cut this thing right there, and flip this down, we're going to have something that's not a rectangle. See that it's slanted here? That when we fold it down, we're going to have a parallelogram. So we're going to have this shape here. Doesn't look the best. Let's get rid of this. All right. So if we cut that right there, so this is going to be 1.5. This is going to be the parallelogram that takes place. So then how do we turn a parallelogram into a rectangle? Well, we can cut this part off and move it over here. And we're going to have that. So it's not the nicest. That's why I did save this for the last. It's not the nicest shape to work with. But hopefully you get the sense of it. So what our new rectangle ends up with, and this is what's important, is the new rectangle ends up having the same exact base. The rectangle has the same base, 1, 2, 3, 4, as the triangle that we started with. So the triangle has a base of 4. And what's the height of this? Yikes. So what's the height of and what's the height of this rectangle? Well, the height of the triangle was 3. The height of our rectangle is half of that, which is 1.5. So if you want to find the area of the triangle, well, if you cut the height in half and do some maneuvering, that's the bell, you should get the area of the triangle, which is 4 times 1.5. And if you do 4 times 1, you get 4. And 4 times 1/2 gets you 2. So 4 times 2 is 6, which is 6 square units. All right, thanks. Talk to you guys later.